JavaScript is slow. Okay, it's not as slow as everyone likes to say. I know it's the meme to just make fun of JavaScript for being a terrible language, but it's not that bad. That said, there are a lot of things that could make it way better. One of those things just got announced by the V8 team, and that thing is a comment. Yes, a comment that can make your code 10 times faster. What the hell is going on here? We need to dive in because I am so excited for explicit compile hints making their way to JavaScript finally. I didn't think we'd ever see the day. This is such a implementation detail type thing, but the more I see the work V8 is doing, the more it makes sense that they're enabling these things. Not because an individual developer building an application is going to use them, but frameworks and the tools that we build that more deeply understand the browser can take a ton of advantage of them. There's been a lot of collaboration between the V8 team and framework authors like the React team in order to add features to make these frameworks and these tools we build with more performant and better. And this is one of those, and the potential is absolutely insane. That all said, neither the React team nor the V8 team are paying me, so we need to make our money somehow. Quick word from today's sponsor, then we're diving right in. There are a ton of different AI app builders nowadays. There's a problem with them though. They all feel like front-end people made them. And I have nothing against front-end guys, you know what I am, right? But I do love backend dearly, and I've always been frustrated these AI app builders didn't know how to do backend. There is one company that knows backend really well in the React world though, Convex. You've probably seen them in my other videos because they sponsor them. They sponsor this one too, but not to talk about Convex, to talk about Chef, which I bullied them into making. The reason I did that is they know backend, and I wanted an AI app builder for people who want a backend that works, like every real app needs. And this is the only AI app builder that handles everything from data storage to sync to file upload to auth and all the other annoying things you normally have to deal with. I could talk all about it, but I'd rather just show you. Here's a real app that I built using Chef. It's a party planner app. I already signed in. You can sign anonymously or with email password. All works how you would expect. But I can go in here, create a new event, random text for the description, location where, whatever, created. So I have this new event I just created. It happens immediately because their database layer flies. Also scales great too. You've heard all about that before though. But check this out. I just went to this event inside of my database, and I'm going to change it here to have a different description. Click save, go back, and it just changed. This is a proper full stack implementation where the data will never go out of sync because it's all live syncing using Convex's platform. It's such a gap between this and my experience using these other tools where the backend and frontend barely can figure each other out. Now they are fully in lockstep because again, the Convex platform is really good at this. You have a schema that's a real code file that sits here. You have your invites, which is a real mutation JavaScript function that makes a ton of sense. It's all type safe from back to front. And this whole app, by the way, one prompt. This was a one-shot. I one-shotted a thing that I couldn't get any of the other app builders to do after hours of trying. It's truly unbelievable. I didn't think it would be this good when I told them to do it, and it is better than I could have ever imagined. Try it yourself for free at soydev.link/chef. Giving V8 a heads up. Getting JavaScript running fast is key for a responsive web app. Even with V8's advanced optimizations, parsing and compiling critical JS during startup can still create performance bottlenecks. Knowing which JS functions to compile during the initial script compilation can speed up web page loading. There's the key. When you give V8 a pile of JavaScript, it has to parse all of it, compile all of the functions and whatnot in it, and get those ready before it can start executing code. Even if you're only using 1/10 of the functions that have been imported through that JavaScript file, it doesn't matter. They're all there. They all have to be compiled before any of the code can run. That's what makes this fun. When processing a script, V8 has to choose for each function. Should it compile it immediately or defer? If a function hasn't been compiled is later called, V8 must then compile it on demand. If a JS function ends up being called during page load, compiling it eagerly is beneficial. Because during the initial processing of the script, we need to do at least a lightweight parse to find the function end. In JS, finding the function end requires parsing the full syntax. There are no shortcuts that they could use with things like curly braces, because JavaScript's a complex language. You can do a lot of different things. There is no simple way for us to figure out where a function actually ends. So they have to parse the full function in order to fix that. And they also have to, after deciding if they want to compile it eagerly, do that on a background thread, even though parts are interleaved with loading the script from the network. If they were to instead compile the function only on call, it's now too late to parallelize the work since the main thread is locked waiting for that function to exist. Just because the function's in your code doesn't mean you can call the function yet, because JavaScript does so much to take our crappy syntax and turn that into performant things running on our machines. And if it hasn't optimized the function you're trying to call, it can't parallelize it when you're calling it. It has to block until it's been optimized. Many web pages would benefit from selecting the correct function for eager compilation. For example, in our experiment with popular web pages, 17 out of 20 showed improvements, and the average foreground parse and compilation time was reduced by over half a second. 630 ms is insane. The feature is called explicit compile hints. It allows devs to control which JavaScript files and functions are compiled eagerly. Chrome 136 is now shipping a version of this where you can select individual files for eager compilation. The version is particularly useful if you have a core file, which you can select for eager compilation, or if you're able to move code between source files to create such a core file. So you add this magic comment in the file, // all functions called on load. As long as you put this at the top of the file, that file will now be prioritized when you load the script. Here's an example, script 1, script 2. Script 1 has this, script 2 has the all functions called on load. And when you look at the logs, when you navigate to the test page, you'll see that the full parse happens for test func 1 before we even get to test func 2. Since test func 1 was compiled lazily, we see the parse function event when it's eventually called. Interesting. So the difference here is that test func 2 skips straight to full parse. We don't see a corresponding event since the compile hint forced it to be parsed and compiled eagerly. Okay, that makes more sense. So here, test func 1 goes through multiple different steps. We have to pre-parse, then full parse, then parse the function, then interpret it. With test func 2, with that comment, it's an immediate full parse, and then the interpreter can run it. It skips meaningful numbers of steps here, which is pretty cool to see if you want to prioritize certain things. What this is reminding me of is a certain framework I haven't talked about in a minute. Qwik. If you're not familiar with how Qwik works, it was built by the guy who made Angular, almost as like an apology for what he did with Angular to an extent. It's like as opposite as possible to what Angular did. The main thing Qwik wanted to focus on was resumability. We need to think about page loads. So a user goes to a web page. We'll say we go to test.com. So the user loads test.com. I guess actually the vertical makes more sense. I want to have multiple layers. So we have the user, I guess we'll say browser. And we have the server. So the browser navigates to test.com. The server responds with HTML for that page. The HTML includes in it some things that we want. So over here, we will parse it. I guess I'll draw an arrow for this. Parse HTML, find script tags. So we parse the HTML and we find all of these script tags on it. And we have to go request those. So we'll say we request script 1.js, script 2.js, etc. And now all of these scripts come back down. It is worth noting that in this time, whatever's in the HTML file is being shown to the user. So if we have a web page that just looks like this, and on this page we have a button, it's a counter. And on click, we want the counter to go up. So the HTML we got has all of this in it. The problem is the HTML doesn't have the JavaScript to trigger this. That's in a different file that's tagged. So now when the user clicks, if they click before the JS has loaded in, nothing happens because the JavaScript that describes what this button does and how to update the DOM when that happens isn't there. So the click event goes nowhere. So now imagine that these scripts are pretty large. We send down the .js files, and now the browser needs to parse those files and do something with them. I'll copy paste my wonderful arrow here, parse and compile JS, then run the JS to bind to DOM. Up until these JS files have been parsed, compiled, and run, the web page is not interactive. So in the time from when we load the HTML file to the point where all of that is completed, this whole window here, interactions don't work for. So once the HTML loads, even if it shows the right content, we have to wait for the JS to be parsed out of the HTML, fetched from the server, downloaded, parsed again, compiled, run, and bound to the DOM. Then the click actions will start to work. The goal of Qwik was to compress this a bunch, especially if you have a ton of script tags. What if we didn't send this all down as these giant individual scripts? What if we inlined a little bit of JS in the HTML to describe basic interactions, or at the very least, queue up events, so once the JS is loaded in, the event can be fired? That's how React works right now. If you load a React page before the JS has been fetched from the server, it will cache events. And then once you have the full JS, it will replay those events against the virtual DOM to get the right result out. Qwik handles this by embedding state into the HTML. The way Qwik worked before is this weird HTML syntax for comments that would tell inline JavaScript, or very short bits of JavaScript like tagged out here, how to interface with the different things in the UI. It's almost like a hibernate, so to speak, where it, instead of having to rerun all the JavaScript to recreate the DOM to rebind to it, this describes to a smaller set of JavaScript what element is attached to what thing, so that it can update this number here. The T8 thing surrounding it is basically a syntax to tell the Qwik framework, this is this identifier. If you want to update the number, you have to update the thing between these comments. It's a weird syntax. They tried to squash it down with Qwik 2.0. Yeah, they put in the elements here the description of what is where instead, as a way to make this more maintainable. It's an interesting choice. The point I'm making here is that all these decisions were made in order for Qwik to get to resume state on the client with interactivity as quickly as possible. That's why it's named Qwik. The whole point of the framework is to go from page loaded to interactions work as quickly as possible. And this mattered a lot, especially for websites with absurd amounts of JavaScript on them, because if you have some JavaScript that's meant to queue events, but you have other JavaScript that's way heavier, all of it has to be compiled before it can run. If I can now have one file that has that comment on top, guaranteeing it will exist as quickly as possible, that on page load, it'll effectively be instant compiled and ready to go, I can effectively DIY Qwik's interactivity into any other tool or framework. And what I've seen from the React team is they're kind of leaning into this way of thinking now, where some features make a lot of sense to build into the framework. Things like hooks obviously belong inside of React. Things like server components largely belong inside of the framework. Some other things, though, like how do you animate an element when it's removed from the DOM, that's not something that the framework should have to do. Some frameworks have tried to figure this out, but the problem is there is no primitive in the browser for when something is removed. You have one for add. You can fade in things. You can do animations when things appear. When something is removed from the DOM, there isn't really an event for that, and the element is gone. You can't CSS or style an element that's not there anymore. The React team could have put a lot of time trying to hack around that, but instead, they waited for view transitions to happen. View transitions are a browser standard that is focused on making it easier to transition elements both between pages during navigation and in and out on the browser in a given window when elements are added and removed. I did a whole video recently breaking down all the cool new things coming to React, and most of it was the view transition stuff, because now they can build a component that you wrap an element with, and it will automatically animate in and out when you remove it from the DOM, because view transitions are a browser standard that solved that problem, because the problem lived in the browser. This is similar. Could the React team have done something crazy with resumability similar to what Qwik does? Probably. It would have been hellish, but they could have done it. Instead, I am almost positive they nudged the V8 and Chrome teams to figure out how to do a better experience in the browser for prioritizing different scripts, so they'd be able to load in the interactive parts as quickly as possible and have the rest come in later. It makes so much sense, and I'm really pumped to see this making it to the browser. This will make everything potentially faster. And frameworks like Next.js will be able to take advantage of this to make your apps get to that interactive moment much faster. Time to interactive is a tough metric to crack, and this is going to help a ton with it. Compiler hints aren't a particularly new thing either. If you want to know a bit more about all this, I did a video I was really proud of. I finally know how CPUs work. This is with Casey Muratori, who comes from the game dev world, absolutely schooling me on microarchitecture and like CPU stuff. One of the things that processors do in order to execute more quickly is guess which path is most likely to be taken, because a given CPU cycle isn't just doing one thing, it's doing a lot. Imagine you're a processor and you're getting this function. Every time you take a step, you do as much work as you can in that step. So we know an integer was passed to f and that this switch statement has to execute something. If we want to do as much work as possible during that step, we can guess which path we think is most likely and continue the compute through that step. If it turns out it's wrong, we can kill that tree and do it correctly on the next cycle. But if I, as the developer, know which of these paths is most likely, instead of letting the processor guess, I can tell it via a compiler hint, hey, this case is more likely to happen, so prioritize this one. The other can happen still, so don't guarantee this path. This isn't hard coding it to case 2 always happens. This is, at an architecture level, optimized for this being the case, and if it isn't, we can interrupt. It's a very small micro optimization, but these optimizations at like CPU level matter a ton. And compiler hints have become essential in application development, especially lower level stuff, to maximize the performance we can get from these things. It's worth noting that basically everyone says don't use these unless you know what you're actually doing, like very well. And I agree. Compilers are very good at spitting out optimized code, including the compiler built into the browser with V8. V8 is a phenomenal engine, and it can do things that are hard to fathom. It's so fast, it's so much shit. This isn't for us to use as application devs. I will probably never write that line. It's very unlikely I'll ever write something that needs to use this all functions called on load, but Next.js might, React might, Remix might, Svelte might. All these other tools we use might find good ways to use this to prioritize the right parts of our code as part of the compiler step. And that's what's so cool here. This will enable framework authors to get our apps to that first interactive moment much faster. And that's a great win for the web. More and more, I expect to see this to be the direction that teams like Chrome are moving in, because new browser features make way less sense. If they were to give us a new syntax for something like error handling or a new way to interface with arrays, our AI tools aren't going to know that those are there and how they work. And getting other browsers to adopt those things is also difficult. So I can't use the syntax because other browsers don't support it unless I polyfill it. And now if I'm polyfilling it, it doesn't even matter. Things like this are wins that my AI doesn't need to know about. My AI code tools, my recently onboarded team of JavaScript developers, none of these people need to know about the new features being added to Chrome that are enabling frameworks to be faster. You can kind of think of us as building on a stack like this. So I'm an app dev. I write app code. The app code works within a framework. The framework gets compiled, and the compiled code gets spit out to a runtime. Historically, we have focused a lot in like this world. How can frameworks improve our experience writing app code? How can we make better application software? How can we make new frameworks that make the app code part in particular easier to write? That part's gotten way too easy. Since we have AI that can generate a lot of the things in this range, we don't want things right below to change. If we were to change out the framework we use, everything above has to be replaced too. The app code has to be blown out. The app devs have to be onboarded for the new framework in order to write new code. So we are now more hesitant than ever to touch things from like here down. We've effectively drawn a line here now where everything above doesn't want to change anymore, because if it does, the tools we're using with like cursor and whatnot aren't going to catch up to those changes. So the question now is, given app code, if we take a given React application, what can we do to improve it? We can improve the framework so that the code comes out faster, or we can make optimizations within React to make our app code better. We can improve the compiler or even build new compilers that will take this framework code and spit out something more performant. We can work on the runtime in order to make it so the code that comes out can be run faster. Maybe we add new primitives in the runtime that the framework can use. But I think now more than ever, this area is where we're going to be seeing change. And the Google Chrome team and the web standards committees are going to be less focused on things we would write as developers in our app code and more focused on what happens down here instead. A great example of this is Scheduler.yield. Scheduler.yield is a feature that Chrome was effectively bullied into adding because the React team wanted it so bad. The role of Scheduler.yield is interrupting your own work mid-action. So if we have an event listener here for a click, we show a spinner, we yield, then we do this other piece, the slow content swap. We want the spinner to show immediately. But if we were to just do the spinner, then do the content swap, we would have a problem, because those, especially if this isn't async, those are going to happen at the same time. So the spinner won't ever be seen because the content swap that happens after will happen immediately as part of the same event. That sucks. And as such, what frameworks like React do, if they want to show you something immediately and then show you the rest later when it's done, or if they want to allow for a user typing on the keyboard to interrupt during a render, a lot of these frameworks have to do weird stuff where they make something synchronous async instead, await a random like no-op thing, or often they'll use a set timeout to 0. And the reason they do that is so they can chunk up the event queue. If you have events in the browser, we have our event loop. The user clicked a button. So this is like the on-click triggered. The on-click has a bunch of stuff in it. It has those parts that we saw here. It has show spinner, which is fast. So spinner, we'll say this takes 1 ms. But we also have slow paint, which takes 800 ms. Ideally, show spinner would be able to happen immediately, and slow paint would be able to queue separately. So we'd want to split these out into their own separate things on the queue. But now imagine, instead of on click, this is on change on an input. We have like a search box, the classic web page where the user is typing search query. And when you search, we update the content underneath. So we triggered this on change with cert with a C, but we didn't finish typing yet. And now imagine we had all of this in one event like we did originally without any of the blocking and any of the other stuff. Then I add a new on change for the rest of this. Then I have to repaint all that again. Then a new event comes in with the space. You see the problem here is sticky keys. We've all had the problem where we're typing in an input on a web page, and every time we press a new key, it gets slower and slower until a bunch come in at once. That's because each key press is triggering something that is slow, and there's no opportunity to interrupt. The reason they added Scheduler.yield is the solution before, they would use set timeout to call the slow paint. But when they called it that way, it would become a new event, and not just an event that goes immediately after, it would get added to the end of the queue. So you'd have to process everything else that's currently pending in order to flush the queue. What the React team wanted was the ability to, in the middle of this event where you have two things, you have something fast and something slow. So we have the slow part, is 800 ms. The React team wanted the ability to, between these, effectively check and ask, hey, is there anything more important? So they wanted to run the fast part, check if there's other things it should do instead, then do the slow part. That way, if there is something more important, it can just kill the slow part entirely, never run it, and put the more important thing on top instead. The ability to interrupt a given task without giving up your position in the queue is the magic of yield. It is telling the browser, hey, stop here. If there's more important work, do that instead. But if there isn't, don't interrupt me. Let me continue doing what I'm doing. Sadly, despite this being, 3+ years ago, yield still hasn't made it into most browsers. It is in Chrome. Thankfully, you can polyfill it with the set timeout behavior, but you don't get the same speed of processing that you do with yield. It allows for not you and me, but for framework authors to make decisions about what happens in the browser. So if you have, again, this search query, you would want, whenever I am typing, to always immediately update the content of that input box. You always want to have that as up to date as possible. And if you have stale results showing, that's fine. Who cares? Don't re-render a giant field underneath on every key press if another key press comes in. Okay, apparently the Firefox Nightly now has Scheduler.yield, but Safari still doesn't. So this is the reason I brought this whole example up isn't because everyone should know about this and use it. It's specifically because you don't need to care because it exists below this line. If you're not working on React Core or other frameworks that you're building yourself, these details don't matter that much. They're cool as hell to know. That's why you're watching this in the first place. I genuinely enjoy these things. But the point here is that innovation above the line is kind of over. I would not expect much more to happen up here because our tools have somewhat cemented what we have there. Similar to how roads aren't going to meaningfully improve or change the way they work on the streets because we have so many cars that expect them to work a certain way. A lot of our tools expect this to work a certain way now. That's fine. It means more innovation has to occur down here, and that's what we're seeing. The introduction of compiler hints in JS fits that perfectly. It allows for things under the hood including framework authors and compilers, to spit out code that will run faster in our runtimes in the browser. I don't want to keep going this deep on weird browser stuff. I think I've made my point. Hopefully this helps you better understand why compiler hints are happening, why you shouldn't use them, and how our browsers and our code in the browser is going to keep improving over time. Curious what you guys think about this one. Was this useful to you, or is this entirely nonsense? Let me know, and until next time, peace nerds.